So, hello guys, today we will be solving Leetcode question 75, which is sort colors. So, first of all, what is the question saying? And as you can see, this question is asked in multiple of tech companies in the coding interview. So, given an array nums with n objects colored red, white, and blue. So we have three colored balls or objects, you can say red, white, and blue, and we have to sort them in place. In place sorting means if we have an array, then we don't get to create another separate data structure to store the array and sort them again. We just need to sort them in place like using multiple pointers. So we will use integers 0, 1 and 2 for red, white and blue to represent the colors, and we don't get to use library sort function. So let's get started with the problem. So obviously in an interview, when an interviewer asks you such a question, you will always start by explaining him the brute force approach for the problem. So obviously the normal brute force solution can be like using a sort function. I know it is written here that we don't get to use the sort function, but in an interview you can say that brute force approach, and the time complexity of this approach will be obviously order of n log n, and the space complexity will be order of 1. Now, moving on to the better approach. Suppose we have an array of multiple 0, 1s and 2s, and we have to sort them in place. So how will we do this? For an order of n time complexity approach, what we can do is take three variables: count 0, count 1 and count 2, and during the first iteration in the array, like we will start iterating from this side, and we will increase the number of counters. Like if we have initialized our counters to 0, during the iteration when our first element is 0, we will increase the counter by 1 and then move to the next element. In the second element, if we will say we will again increase the counter by 1 for count 1, and so on. So after the full iteration, we will get count 0 as 2, count 1 as 2, and count 2 as 1. Now we will reiterate through the array, and we will sort them using this count function. So let's suppose we are at the first element, and we have a count 0, 1 and 2 as 2, 2 and 1. So we will start with count 0. Unless count 0 reaches 0, we will fill the array by zeros. Like for the first element, like count 0 is equals to 2, we will decrease this by 1 and here place 0. Move on the next element, similarly decrease this by 1 and place 0 here. Now that count 1 is 0, we will move to count 1. Count 1 is 2, we will decrease this by 1 and place 1 here. Again we will move on to the next element, decrease the count to 0 and place 1. Now count 1 is also 0. Let's We need to move on to count 2. Here we have added our extra space, don't mind it. Now count 2 is 1. We will decrease the count 2 to 0 and place count 2 here. So this is our better approach. Here the time complexity is order of 2n, as for the first iteration we iterate through the array to count the number of zeros, ones and twos, and for the second iteration we overwrite the given array and fill the positions here. So the overall time complexity is order of 2n and space complexity is order of 1. So now let's talk about the most optimal approach, and here we'll talk about the intuition for this first. So let's suppose we have an array. We have multiple elements here, obviously 0, 1 and 2's. Let's make this as 2, 0, 2. This is the optimal solution, and here we are going to use 3 pointers. This approach is also known as a famous algorithm called the Dutch national flag algorithm. Or we can also call this Max Vestrappen algorithm, like pun intended. Now, we in this three pointer approach we will take three variables: low, mid and high. Let's talk about the intuition first. Suppose we have a array of some elements including, like, obviously 0, 1 and 2's. Now suppose this is our original array which is unsorted. Like, anything can be here, 0, 1 and 2. Like, for the first zeroth pointer and the last n minus 1th element, uh, our separate sections are obviously sorted, like zeros, ones and twos are sorted, so we don't have to place our, like, do something here. For the first one element we will call this as low, and the zeroth element before that will be obviously low minus 1. The last one element or the first element of the unsorted array will be mid, and the previous one will be mid minus 1, and the last unsorted element will be high, and the first two will be high plus 1. I know this will sound a little complicated, but don't worry, we'll see in a little while why this is very simple. Let's remove this. We just have to take the main low, mid and high pointers only. So now suppose our we'll start with iterating using array 0. Let's use a different color. We will use mid pointer to traverse through the unsorted array. Let's suppose array mid is equals to 0. So if there is a 0 present here and we need to sort the array, how will we do so? Suppose, like, we can place 0 here in any of the elements, and this will be the correct position for the 0. So what if we swap this one and this 0, like this 1 comes here and the 0 comes here? It will be again sorted because the I because the series will be 0 0 0 and 0, and then followed by 1 1 1 1, and unsorted part also gets an 1. So obviously this will be the best approach, as we kill two birds with one stone. Our first section is also sorted, our second section is also sorted. Now after swapping, what will we do? This 1 is here and this 0 will come here. Well, like this 0 will come here and this will come here. We can uh, increase the low pointer, because this will be technically 0 and this will be technically 1. So here it will 1 and here it will be 0. So we will increase the low pointer and we will increase the mid pointer, and we will be again at the starting position how we started the array, but our unsorted portion reduce by 1. Now this is our unsorted portion. Okay, now let's see for another portion. Let's keep the array as it is here. Now suppose we get, instead of a so this is our unsorted. Let's suppose instead of getting a 1 here, like this is obviously not 1. Let's suppose instead of getting a 0 here, we get a 1. Now in this case, as you can see, the section is already sorted. We have got uh, zeros followed by ones, so we don't need to do anything. We just need to increase the mid to the unsorted section, and this array will be sorted. Oh, so let's write the pseudocode for the following till like what we did till now. The first point was array of mid equals to 0. Here, what we did was we swapped array of mid and array of low. Like here, low and mid was 0 and 1. What we did was we swapped them. It became 0 and it became 1. Afterwards, what we did was move the pointers to the next element, mid plus plus and low plus plus. Now mid element, now if the second, if the array of mid equals to 1, what do we do here? We just increase the mid pointer, because the that portion, because this portion will be already sorted if we get 1 here. Now for the last part, if array of mid equals to 2, so what do we do here? Let's talk the intuition behind it. If this is our unsorted portion and we get a 2 here, followed by the sorted portion which is 2, this is the last element, this is the high plus 1 element. I don't care whatever here, whatever the element here is, it can be 0, it can be 1, or it can be a 2, and this is the high element. So what do we do now? Let's suppose, uh, actually, let's not suppose that 2 is here. If 2 is here, we can just uh, move the array, move the high pointer little behind. Like, it is 0 and 1, and this is mid. So what can we do now is we can again swap these two elements, and after swapping, how will our array look like? Like 0 or 1 will come here and 2 will come here. As you can see now, this portion is sorted. Now this portion is sorted. So the unsorted part remains only this much. So we shift our high pointer to the previous element, and this becomes our unsorted portion. So if array of mid equals to 2, what do? We swap array of mid and array of low, array of high, and mid does not change its position, because if it is 0 or 1, we can again, like for 0 we can swap it to the previous low element here, 1 or something, and we can follow the further operations. And if it is 1, then we can just move the mid pointer to the next element. And for keeping that unsorted boundary as it is, we can decrease the highest element and high pointer, and it will come to before previous element. So it is high minus 1. High minus 1 will be the highest pointer. So let's do a dry run of this following solution. I know this will sound like all the explanation doesn't make sense so much right now. Let's see a dry run of the solution. Okay. Let's write the elements 0 and we have higher pointer, low, and mid pointer. And let's write a pseudo code here too. If array of mid equals to 0, we swap low and mid. We increase the low and mid pointers. If array of mid equals to 1, that uh, array is already sorted. So like that portion of array is already sorted, so we just increase the mid pointer. Like remember this intuition, always imagine this in your head. If array of mid is equals to 1, so this portion will be obviously sorted. We just need to decrease the unsorted portion, so we increase the mid by 1. And finally else array of mid equals to 2. So here what we did was we swapped array of mid and array of high, and we decreased the high pointer, because this will be our unsorted portion, because 2 comes here and this becomes sorted. Now let's start with the dry run. let's move this section let's move this section a little bit towards here. So let's start with the dry run. Now our first element is 1. So what do we need to do now? We need to swap low and mid. Sorry, the first element is 1, so we just need to increase the mid pointer. Mid comes here. Now what do? The mid element is 0, like array of mid is equals to 0. So what do? We swap array of low and array of mid. How will be the array looking afterwards? This portion will become 0, this element will become 0 and this element will become 1. We swapped 0 and 1 and we increase our low and mid pointers. So this will become low and this will become mid. Now, what is mid pointer pointing at? It is 2. So what do we do in that case? We swap array of mid and array of high. So this 2 and this 2 will get swapped. It will be same, but the height pointer will decrease and this will be the high pointer, and we increase a mid element, but this will be wrong. There is an error somewhere. What did we do? Mm, swap array of mid, array of high. Acha, we don't increase the high mid element, so the mid element will be here only. Now again, array of mid is 2. What do? We swap array of mid and array of high. Array of mid and sorry, array of high. So after swapping, what does this look like? Array of mid will become 0 and high will become 2, and high pointer will decrease. It will come here. Now array of mid is 0. What do? We swap array of low and array of mid. What does this look like now? After swapping, it will be 0, it will be 1, and both low and mid will increase by 1. Now array of mid is 1, we just increase the mid pointer. Again array of mid is 1, we increase the mid pointer. Now array of mid is 2, we swap with high. Array of mid and array of high will get swapped. What will it look like? It will be 1, it will be 2, and the highest pointer will decrease. Now what is our unsorted portion? This is our unsorted portion. We'll continue. Now array of mid is 1 here, so we'll increase the mid pointer. Now this is our unsorted portion. Array of mid is 2, we'll swap it with the height pointer. What will it look like? It will become 0 and it will become 2, and the height pointer will come here. Let's shorten this. Right, just here, high. So mid and I are like this. Now array of mid is 0. What do? We swap with the lowest pointer. Now this will become 0, this will become 1, and will increase both low and mid. Again it is 0, so what do? We swap it with low. So this will become 0 and this will become 1. Low increases and mid increases. Now our mid element has finally passed high. It means, like, originally what was the unsorted portion was like, it was mid, it was high, this was high, and this was like ones, so this was low. After like, if we traversed this completely, the mid will surpass high pointer and our unsorted portion will become 0, like we don't have any more elements to sort. So as you can see in the example, how does this look like? Few elements are all 0 followed by 1 and then 2. So our array is sorted in order of n time complexity. So why is the time complexity order of n? Let's look at it. At any point after the swapping elements, like if it is a 0, it is a 1, or it is a 2, what do we do? In these case we swap, and in this case we just increase the pointer. So at any point only one element is getting sorted. As you can see, at any point only one element got sorted and the unsorted portion decreased uh, one by one. So the time complexity will be order of n and the space complexity will be order of 1 because we didn't use any extra space. So this is the uh, optimal solution, also called as Dutch national flag algorithm. And for the people using Java language, in C++ we can use the swap function to swap between elements, and for people using Java, uh, we use a temporary variable, like we'll declare a temporary variable and store, like if we want to swap x and y, suppose we want to swap an x and y, so our temporary variable will be x. So and we'll place x is equals to y and y will be the temporary element. This is the template for swapping in Java. Like let's do with an example, like we have to swap 0 and 2. So our temporary will be 0, our x will become y, which is 2. So x will be y, like this becomes 2, and then our y becomes temporary is 0, so this becomes 2. So both these elements are swapped. So with this we end our discussion of the Leetcode question 75. This is a very good question, and the Dutch national flag algorithm, or Max Strappen algorithm, gives us insight on how to use three pointers efficiently. Thank you.